So you click on a study and it loads. And from where you're sitting, that's the whole experience. But there's actually a whole other chain of events happening on the other end. And most people who work in imaging every day never actually see it laid out. So in this video, why don't we go through it in a simple fashion? Everything you're about to see is one conversation between two computers, your laptop and a server sitting in the hospital's data center. Your laptop is what's called the client, the one asking. The server, on the other hand, is exactly that, a server. Same relationship as ordering at a restaurant. You order, the kitchen fills it. Every step from here is just that conversation, getting set up correctly before the images, or the food in our analogy, can actually come out. The link you clicked isn't the server's real address. It's a name that's easy for you to read. But before anything else can happen, your laptop has to look up the actual numeric address behind the name. This is called DNS, domain name server, and that's exactly like tapping a saved contact instead of dialing a number from memory. Your phone does the lookup for you instantly every time. Here's a step people miss. Working remotely, you're not just reaching out to the hospital across the open internet. Your laptop first connects through a VPN, a virtual private network, a private, encrypted tunnel between you and the hospital network, instead of your traffic traveling across the public internet where anyone could try to intercept it. Even once you're in that tunnel, the hospital's firewall is still checking every request against its rules. This device is allowed. This type of traffic is allowed. This isn't. If a request does not match the rules, you don't get an error. It just goes nowhere. That's the difference between a private guarded tunnel and an open road with a checkpoint partway through. Two separate layers of is this allowed, both quietly happening before anything else. Now you're inside the tunnel and past the firewall, but one more check happens before any patient data flows. Your laptop verifies it's genuinely talking to the hospital's real server, not something impersonating it. This is exactly like calling a tow truck. The app shows you the driver's name, photo, and vehicle before they arrive, sent to you directly by the company you called, not by the driver. When the truck pulls up, you check it matches. Your laptop does the same thing with something called a certificate, proof of identity backed by a trusted third party. Before it trusts the connection enough to send or receive anything containing PHI. This is also where encryption kicks in, scrambling everything between you and the hospital so it can be read if intercepted. Even a server built entirely for imaging runs more than one program at a time. Sometimes you have a certain program that's responsible for maybe serving modality work lists to your devices like CT scanners and X ray machines and whatnot. And then maybe you have another one that's responsible for accepting and sending out images, such as DICOM images specifically. And ultimately, your request needs to land on the right one. And that's where a port comes in. So if we draw an analogy here, if a server's address, the IP address, is a building, then the port is a specific apartment or office number where you would find that respective service. Now, in imaging, that's not even abstract. The piece that receives DICOM oftentimes listens, for example, on port 104. It's very common in modern systems, and that's a real number that you'll see written into firewall rules and network diagrams, not just a teaching example. Now, a study like this isn't one small file. It's often hundreds of images. That data doesn't travel as one solid block. It's broken into pieces and sent separately, the way movers ship numbered boxes instead of one impossible truckload. One system handles getting each piece there. A second system keeps track of the numbers, confirms nothing's missing, and asks for a resend if a piece got lost or arrived damaged. For a diagnostic image, that's not a minor technical detail. A corrupted or incomplete image is a patient safety issue, not just an inconvenience. So let's recap what just happened. First, your laptop looked up the real address hiding behind that link. That is the DNS. Then it traveled through a private VPN tunnel and got checked against the hospital's firewall rules before it was allowed any further. Once inside, it confirmed it was actually talking to the hospital's real server, not an imposter, before trusting it with any patient data. From there, it found the exact program on that server responsible for serving out images. Not just the building it lives in, but the right door. And finally, every piece of that study got delivered and double checked, so nothing arrived missing or damaged. That is the whole chain. That happens every time you open a study.